Have you ever experienced this scenario? You're sharp in the morning, clear, decisive, running at full speed. And then somewhere between noon and say 3 in the afternoon, you hit a wall. And it doesn't seem to be any amount of coffee that's going to fix it. I want you to watch this video carefully because what's happening in your body during that crash is not just tiredness and it's not laziness. And while stress may be part of the picture, for many people there is something else happening, something that is measurable, something with a specific name and a specific number that the standard advice completely misses. My name is Dr. John Torquato. I'm a board-certified family physician, and I specialize in metabolic health and executive performance. And today I'm going to walk you through the physiology behind that afternoon crash, the number your annual physical probably isn't checking, and the scientific finding from 2024 that changes how we should think about the problem. First, let's talk about the physiology, with what happens mechanically every time you eat a meal. When food enters your body, it's broken down into glucose. Glucose enters the bloodstream and the blood sugar rises as a result. Your pancreas detects that rise and releases insulin. Insulin is the key that unlocks the cells so that glucose can enter in and be used as energy. That's the system. And for some people, it works beautifully. Glucose rises, insulin responds proportionately, glucose returns smoothly to baseline, energy remains stable. Now, here's where it gets interesting. For a growing number of adults, the pancreas is releasing more insulin than is necessary to do the job, sometimes significantly more. And when insulin clears glucose too aggressively, the blood sugar doesn't just return to baseline, it actually drops below where it started. And that relative dip, as well as the speed at which it gets there, can leave you feeling foggy, irritable, and mentally depleted. Now, the brain is exquisitely sensitive to fuel supply. For instance, it consumes about 20% of the body's oxygen despite being only 2% of the body's weight. And so when big changes happen fast, the brain tends to notice first. For some people, that afternoon wall is not a willpower problem. It may be a post-meal metabolic overshoot, a biology problem, not a character problem. And now I want to be careful and honest here. That afternoon slump has many possible contributors. Sleep quality, it matters. Meal composition, it matters. Hydration, circadian rhythm, and even the natural post-lunch dip in the core body temperature, all of these can play a role. And stress can absolutely affect energy, and sometimes a crash is just part of the normal being of human. But in my 27 years of clinical practice, I've seen a pattern that is consistently overlooked. Some people who crash hard every afternoon and who don't respond to the usual fixes are carrying a specific, measurable, metabolic shift that most standard blood panels are not checking. And that brings me to the number. I want to tell you about a patient. He was successful, he was professional, he was in his late 50s. He wasn't diabetic and he wasn't overweight. And his fasting glucose was normal. His hemoglobin A1C, 5.2, was also in the normal range. His doctor told him at the time that everything was fine, but he knew that something was off. I mean, he could still produce, but it was taking so much more effort to produce the same amount of output. And he recognized this, and so he sought deeper understanding, because it was taking longer to recover between those demanding weeks of work that he had done. And when we looked deeper, when we measured his fasting insulin and calculated something that is called the HOMA-IR, the picture changed completely. That's HOMA-IR. It stands for Homeostatic Model Assessment of Insulin Resistance. It's a big name, but it's just a calculation that uses your body's fasting glucose and your body's fasting insulin to estimate how hard your body's actually working to keep your blood sugar in the normal range. Well, this man's HOMA-IR was markedly elevated. There was no evidence of this in any of his other labs, but he was insulin resistant. His pancreas was working at a significantly harder level just to maintain the same glucose. Well, there's an analogy that I find that helps most people. So imagine two cars driving down the highway. Both of them are traveling at 60 miles per hour. On the outside, they're identical. Same speed, same roads, same journey. The only difference is if you look at the tachometers, one engine is running at 2,000 RPMs, relaxed, cool, efficient. The other is running at 7,000 RPMs. It's redlined, strained, burning through reserves. Now, which one of those two engines is going to fail first? So in this analogy, glucose is your speed. Insulin is your RPMs. And most annual physicals only measure the speed. They're only checking to see whether your fasting blood sugar and your A1C are normal. That tells you if you have disease. It doesn't tell you if you're running optimally. If those labs are normal, you're given a clean bill of health. But your body could be running at 7,000 RPMs. That's a metabolic strain. It could be running at that level for years before your glucose ever looks abnormal. And that's the gap between normal and optimized. Normal tells you that you're not sick. It's the cliff. It doesn't tell you that you're working harder than you should just to stay where you are. That's not the cliff. That's the slope. And those extra RPMs, that hidden metabolic load, is where afternoon sharpness, cognitive stamina, and eventually long-term brain health quietly erodes. Now, according to NAIN's data, approximately 38% to 40% of non-diabetic adults in the United States have insulin resistance by the HOMA-IR criteria. Get what that means. That's approximately 4 out of 10 people walking around the streets with normal blood sugar and an engine that's running hotter than it needs to be. They are insulin resistant and don't even know it. Now, here's where the story gets genuinely surprising. And this is the part that most people, including a lot of physicians, really haven't even heard yet. In 2024, a team of researchers in Australia published a study that looked at the relationship between peripheral insulin resistance and how the brain metabolizes glucose. They took healthy adults, people with no diagnosis of diabetes, no serious health conditions, and they simultaneously measured their insulin resistance, their brain glucose metabolism using the PET MR imaging, and their cognitive performance. Here's the finding that should stop you in your tracks. The strongest relationship between insulin resistance and reduced brain metabolism was actually seen in younger adults. These were people in their 20s and 30s. These were not older adults. These were the younger ones. Now just sit and take that in for a minute. We tend to think of insulin resistance as something that catches up with you later in life, after decades of poor diet, and after retirement, and after the damage is done. But this study suggests the opposite. The brain glucose metabolism appears to be the most sensitive to insulin resistance in the early and mid-adulthood. Exactly the years when people are building careers, leading teams, depending on their cognitive performance the most. It might be that by the time they are in their 40s and 50s, they've learned to compensate to a degree, but that doesn't mean the damage isn't done. And where was the effect the largest? It was found in the prefrontal cortex, the parietal cortex, and the temporal lobes. These are the regions that are responsible for what is known as executive function. That means the kind of brain work that involves complex decision-making, the kind of brain work that is working memory, that involves focus, impulse control, the exact mental abilities, the exact cognitive capacities that high-performing professionals rely on every single afternoon. And the researchers also found that higher insulin resistance was associated with measurably lower working memory. Now remember, we are not talking about diabetics. We are talking about otherwise healthy adults. Now this paper was published in the Nature journal. It has nearly 6,000 scientific reads, and it has been cited 17 times in even less than 2 years. And it points to something I believe is going to reshape how we think about brain aging and metabolic health in the coming decade. The afternoon crash may not just be about how you feel at 2 p.m. It might be an early measurable signal that your brain is not getting the glucose it needs to function at full capacity. And that signal can appear years, perhaps even decades before any standard lab test ever flags a problem. Now, your leadership depends on your biology. If you connect this with something practical, most leadership books focus on psychology. Other leadership books emphasize communication or maybe strategy. And while all of that matters, very few leadership resources discuss physiology. And yet, every decision you make, every critical decision, every creative insight, every difficult conversation, every moment of patience under pressure, all of it depends on the billions of brain cells that produce energy. Those cells need oxygen And those cells need glucose regulation every second of the day. And they are exquisitely sensitive to any decay in the delivery of those two substances. The quality of your thinking actually sets the ceiling on the quality of your leadership in this world. And the quality of your thinking depends in part on the health of the organ that is doing the thinking. Now, this is not just a philosophical thought. This is actually biology. And there is a genuinely encouraging part, and that is this. Your biology is both measurable and trainable. You can alter that part. Now, if you recognize yourself in what I've described, that afternoon fade, the feeling that something's shifted, even though your labs seem to be normal, the sense that you're operating below where you should be, here's what I'd like you to take away. What you're describing is not necessarily a character flaw or a sign that you're doing something wrong or proof that you need a vacation. For some people, it may be there has been a measurable metabolic shift that has started years before any standard blood test catches it. And the next best step is to understand what to do about it. In my next video, I walk through VO2 max. That is the single best predictor of long-term cognitive performance and all-cause mortality that I know of in all of medicine. And I show you exactly how building your aerobic engine changes your metabolic response to every single meal. If you want to check that out, click right here to view mental stamina and VO2 max, how good leaders become great. If you appreciate this kind of content, please let me know by gently tapping the button below. You can also drop a comment and tell me what time of day you typically hit your wall, because the timing is clinically meaningful, and I read every comment. And if you hit the follow button, whenever I make video content like this, you'll be notified. I'm Dr. John Torquato, and I'll see you in the next video.